So hello again. Tonight we're going to talk about impractical extraterrestrial precursors. May sound like clickbait, but it's more a matter of me trying to come up with a short title. So once we get into it, you'll see that the title is applicable. So I was watching videos this week, as is always dangerous for me to do, and I saw an article about the James Webb Space Telescope detecting artificial lighting, like light bulb lighting from Proxima Centauri b. Proxima Centauri b. Proxima Centauri is a star of the Centauri star system, which is around 4 light years from us. Proxima is one of the stars, and B is the first discovered planet around Proxima Centauri. And it's supposedly in the habitable zone. It's really close to its star, and its star is a red dwarf, so there's downsides. But as the planet goes in front of the star, and they zoom in with the James Webb Space Telescope, and they put basically the covers, the electronic covers over all the star, and they're only looking at the planet, they can now do an analysis of light coming from what would be the side of the planet opposite the star-facing side. And they saw light there. And then a lot of people were like, it's impossible. That telescope's not good enough for doing that. And then I read an article where science and technology folks did an analysis on the capabilities of the James Webb Space Telescope. And they said, I don't know what they detected, but it is certainly possible for that telescope to detect a few pixels worth of brightness on the dark side of a planet that far away. So is it technically feasible? Yes. Has it been confirmed by other instruments? What other instruments besides the James Webb Space Telescope have that level of capability? So the only thing they can do is have other science teams use the exact same instrument on the exact same planet, maybe a couple of 100 days from now, and see if the observations are still there. Yeah, it's lighter colored pixels on the what would be not starlit side of that planet. Well, maybe they're going to do some spectroscopic analysis on that light and see whether it's, I don't know, lightning as opposed to artificial lighting, or whether it's bleed over from the overly lit sun side of that planet. We shall see. So what am I referring to as precursors? Think of it as cart and horse. The horse is in front of the cart. It's there to pull it. Therefore, therefore the cart comes after the horse. The horse comes before the cart. Same sort of thing on life beyond Earth is, we need to understand that if you think you just detected some extraterrestrial activity on an exoplanet, the first thing you have to think about is it really possible for there to be habitation of that exoplanet by smart living thing, sentient life? If you don't have the things that come first, then you're not as likely to have the advanced things that come later. You might be able to skip a few steps or redirect some direction in order to do things more quickly than has been done on Earth, but you still have to go through a number of gates. Think of these gates as requirements. We're looking for something that is going to be self-aware, cognizant of their existence in the greater universe. Much like us, they may not know why we're here, but it's not going to be much use in us finding a bunch of folks that believe that their planet is flat, or that their planet is the center of their solar system, or the center of their galaxy. So we're looking for the smarter ones. They have to be communicative, documenting things. They have to take gained knowledge and generationally pass it on. Hey, I just discovered this. Write it down so the next generation can learn that in school. And it has to be technologically progressive. It can't be, regressive, not constrained by dogmatic threats that might otherwise curtail collaboration or intellectual advancement. Don't shoot the smart people, that kind of thing. They have to be long lasting, because you can't develop everything you need in a short enough period of time. So you have to have both an environment and a society that is going to be around for a while. And if you have that, you're going to need to achieve a critical mass of population. It can't be just a planet that has 5,000 people on it. It's got to be a planet that has at least probably dozens of millions of people on it to have the diversification of offloading tasking. You can't study much about interplanetary science if you also have the responsibility for growing the crops or doing the hunter gathering or keeping the house or cleaning the clothes. Or you've got to have enough people in your population to diversify all that stuff so you can outsource it. Have to have something that presumably you'll experience respiration. So you have to have an atmosphere that's either endurable or controllable. In other words, it can't be so cold that physiology won't work in the ice, that kind of thing. You have to have a plentiful source of nutrition. Has to be food around so that you're not always spending your time hunter gathering. And if you're like other animals, you're going to create waste that needs to be eliminated. And when you get that many millions of beings, you probably want some kind of a sanitation system to avoid possibilities of diseases from things piling up. If you look back in history, this is one of the reasons why New York City dramatically changed from horse-drawn things to internal combustion engine things, because the horse manure was just piling up too high and they had sanitation problems. If you don't have solutions for these requirements, probably going to be impractical for you to have advanced species on your planet. But the planet's got to be habitable, essentially. If your planet is too close to a parent star that is a blue-white, you're going to have an increased solar wind, ultraviolet radiation, X-ray radiation. If it's an orange dwarf star as opposed to a yellow like ours is, then you're going to have an increased solar wind and more flares. And if it's a red dwarf, in order for you to be in the habitable zone with liquid water, you're going to be fairly close to it, which means you're going to be subjected to a lot of coronal mass ejections, which could wipe out life on your planet. In order to counter these kinds of things, a bigger planet, farther away, with a bigger magnetic field, can defend itself from solar wind and flares and coronal mass ejections. There's no way for, as far as we know, a biological being to fend itself off from these radiation storms long enough to create some technology to mitigate that bombardment. In other words, you don't go, hey, we're living in caves and every time we go outside, that person dies. Let's create some technology. Well, there's not going to be enough of you. You're not going to advance the technology enough to create even a spacesuit. And you can't count on evolution to improve things because it takes time. You're not going to have a planet bombarded by radiation. I just grow a thicker skin and improved eyes. That takes time. And if you're too close to your parent star, you're probably going to be tidally locked. In other words, your planet won't rotate. It'll just go around its star, kind of like our moon goes around the Earth. If it does, then the star-facing side will be too high a temperature for liquid water to all boil off. And the far side will always be in darkness, so it's likely to be too cold, not habitable. So the environment wouldn't be, a tidally locked exoplanet would probably not be survivable. So what if your planet's too small, gravity's too light, your star is too dim, or you're too far away from it to get enough heat? If it's too small and your gravity's not heavy enough, much like happened on Mars, your breathable air will bleed off into space. If it's too small or doesn't have a sufficiently strong magnetic field, then once again, your breathable atmosphere will be stripped away by solar wind, which kind of like happened on Mars. Let's say you have an atmosphere, but your star is deeply red. It's a red dwarf, and it's producing a lot of infrared, a little bit of red, but it's too dim. Remember, photosynthesis, if you ever did some indoor hydroponics, really likes them near ultraviolet lights because there's more energy per photon. So if you're around a red dwarf star, don't expect some fastly growing high development plant life. And if it's too small and it can't sustain its atmosphere, life is not going to live sufficiently long. Let's take it the other direction. You've heard of this thing called a super Earth, or an exoplanet that is quite a bit larger than Earth. There was an episode of The Orville where they visited a planet that had, I think it's 8 times Earth gravity. And you had to wear a special spacesuit that had a force field built into it to avoid you being crushed. Well, let's say that you go to an exo world and the gravity is only 4 times what it is on Earth. Could you even stand up under 4 times gravity? I don't think so. Maybe, 1.5 times gravity, but even astronauts and jet fighter pilots, they have a limit, and the instantaneous limit is around 10 Gs. Their sustained limit is around 3.5 Gs. You're not going to get much out of a planet that has, 4, 6, or 8 or 10 times the gravity. Even plants. Think about plants when they grow, when they pop up out of the ground. They pop up out of the ground with flimsy little shoots that have to grow and get bigger and get larger diameter stems in order to support their own weight. And for some plants, we even put a stick in the ground, a little bamboo stick in the ground, and then strap the plant to it to hold it up under Earth's gravity to keep it from falling over and becoming a running vine. And if you were on a planet that had a lot more gravity, you're not going to have any flimsy above surface plants that are growing. They need to come up sturdy from the ground. If you've ever watched bamboo culms grow, they come straight up out of the ground as a pointed end of the tube diameter of the bamboo. That would probably be vertically stiff enough to survive. But the little branches wouldn't, because they would break off. So you would have to have the actual column of the bamboo be photosynthetic in order for it to get the energy to grow itself taller. Any nourishment on a planet with that heavy a gravity would likely be subterranean, because the plants couldn't grow up above the surface. So roots, nuts, tubers, those kind of things would be main sources of food. Anything on the surface would have to be flat to the surface, so molds and lichen, which there are things that eat that on this planet. Animals and sentient beings would not be tall. They'd be short, squatty. Think of if you had an intelligent species like a hog, because they're fairly smart. They're low to the ground. They have stubby legs, except these would be hogs the size of dachshund. So very low to the ground. So they could be extraterrestrials. They're not going to have what they need to create an advanced species. If you did have more gravity, your atmospheric pressure is going to be greater, because the atmosphere is going to be held down to the planet by gravity and therefore compressed. So if you think about, I'll just fly a plane. The plane's mass, how weight influences the mass, may be such that the plane will never lift off the ground unless it's very small. So no big passenger jets, because the gravity is too heavy and the drag is too much on the plane. But even rockets may not work. Sure, physics and chemistry will still work, but they have to be able to produce enough F equals ma propulsive force to get it off the ground. And if you ever looked into rocket propulsion, liquid rocket propulsion is less than 2 to 1 on the ratio of lift versus mass. And for solids, I think it only gets up to around 3.5 to 4, and they burn out very quickly. So if you are expecting a spacefaring species from a very large super Earth, they may not have ever been able to get off the ground. And if you look to the history of the human species, there are times when things went off the rail, so to speak, and it took hundreds of years, if not collectively thousands of years, to get things back going again. Many years ago, I did a presentation regarding how many times the human species had discovered that Earth is not the center of existence and that the planet is not flat. And I found that there were actually 4 times. We figured it out, and then we lost it. We figured it out, and then we lost it. Figured it out and lost it. Figured it out and was told, don't think about things like that. That's heresy. If you are on an exoplanet where they're really good at advancing things, but only so far. And then the politics, the dogma, the wars, the dictators, wiping out the smart people, that all comes into play, and you sort of reset things. And not only do you have to kind of start from where you were and go forward, if you're regressed enough, you may have to start back from where you were and then work it up again. But some people think that we need a good war every so often in order to do the necessity of invention kind of thing to create advancements. I can't give a verdict one way or the other on that because I live in a society where, yep, we create all kinds of advanced technology, and then we find out the bad things we can do with it. So I needed to pick a good example of where we might have skipped ahead but didn't. So this is not to say that we regressed. This is just to say that we could have gone down a different path and things might have been more advanced just by having chosen the different path. So electric motor vehicles, not the hybrids, the true battery powered ones, the EVs, those actually predate internal combustion engine vehicles or ICE vehicles. So the first battery powered, carries people around vehicle was in 1839. But what do we do for batteries? Well, it wasn't until 1859 that there's a guy that invented lead acid rechargeable batteries. From 1839 to 1859, all the batteries that they used in the vehicle were essentially chemical one-time use throwaway batteries. Having a rechargeable battery, even if it was low capacity and took a while to charge, was a major advancement. In 1879, although the electric incandescent light had been invented for quite some time, Edison made the first practical commercial volume incandescent light in 1879. But how did you power it? Well, it wasn't until 1882 that he had the first electrical power grid in New York City, but it was DC, so it couldn't go very far. The first alternating current or AC electrical power grid was actually in Rome, Italy in 1885. So by 1885, you had access to a power grid that could be used for charging. You had access to, sure, limited, but you had access to rechargeable batteries, and you had access to DC powered motors for use as propulsion. But they didn't make cars using that. A guy came along named Carl Benz, as in, Mercedes, that Benz. He made the first commercially practical internal combustion engine vehicle in 1885. He had a couple of problems, though. Where do you get the gasoline? Where do you get the lubricants for making things not be squeaky? Where are you going to get better tires? Because absent roads, the tires didn't last very long. Early EV batteries didn't have sufficient capacity for the range that was desired of them. It took too long to charge. There were no charging stations anywhere, and the batteries didn't last long enough to satisfy customer expectations. Sounds pretty familiar to where we are today, although things have improved dramatically. So holding back EVs was no product volume capacity. Everything was essentially handcrafted, slow to assemble. And since it was handcrafted, inconsistent quality and reliability, no charging stations, and the tires weren't durable. Now, ICE vehicles had all these same issues that EVs had, but ICE vehicles could carry around spare cans of gas that they call jerry cans. And that was how they extended their range, because the initial ICE vehicles were like 4-cylinder, highly polluting, not very efficient internal combustion engines. So you carried extra gas with you. If you think of early Jeeps, on the back of the Jeep is that frame, and on the frame it carries a tire, a spare tire, and a gas can. While the gas cans got bigger and the tires got bigger and you didn't use it as often, that's how you realized how things used to be. You needed extra gas and you needed spare tires. The difference was that the ICE vehicle community had well-heeled industrial backers who saw no issue to colluding to dominate the marketplace. And if you're not familiar with that, here's what happened. So at Henry Ford, John D. Rockefeller Firestone, not colluded for ice domination, then EVs might have first come out as the winner. So in 1908, which is well after that first EV, well after it had a battery that's rechargeable, they came out with the Model T, the first production volume commercial car. But what did it need? If you're going to make that many cars, you're going to need fuel. You're going to need lubricants. You're going to need filling stations. You're going to need durable tires. Well, luckily, Ford could just give his friend Rockefeller a call and say, hey, if I make the cars and you do the oil drilling, gasoline, production and lubricant production and make all the filling stations, we've got a win-win scenario here. So that's what they did. They got together and said, I'll make the cars. You make the stuff that the cars need. Great. Who's going to make the tires? Well, they didn't think about the tires initially until people started saying, oh, yeah, I want to go on a trip from New York to Chicago. I have to carry 5 or more tires with me because tube tires going over rocky roads or unpaved paths aren't going to last very long. So they got in touch with their friend Firestone and they made volume production durable tires. So now you would have a tire that you only needed one spare. But they also at the same time said, why don't we talk to our friends in government? They had friends in government. They're the ones that allowed the collusion to take place. They had friends in government and they said, why don't we make some roads? Why don't we take taxpayer dollars and pave some roads so that our vehicles don't need a lot of spare tires? Because spare tires were not only a cost, if you were going a long distance, it was also something that slowed you down because you had to stop, jack up the car, take the wheel off, replace the tire, or patch the tube, put the tire back together, put it back on the hub, and then you could drive on again. That would take you longer than, 30 minutes to fill up your EV. But that's just, not really comparing apples to apples here. But yeah, they had to have more sturdy tires, better roads. How do I know these guys actually colluded? They actually went on adventure trips together. You can read about this. I went over to the Edison Ford estate over on the west coast of Florida, and they've actually got information there that, hey, Ford, Firestone, and Edison used to have fun times in Southwest Florida, kind of camping trips for them until they started building homes there. So they knew about electricity. So you might be familiar with the fact that the early cars were crank started. So you'd rotate a crank, which would rotate the flywheel, which would, okay, where'd the electricity come from to spark the spark plugs? Oh, there was a flywheel generator. So as you turned the flywheel, you would not only be moving the cylinders up and down, you would be cranking up the current to fire off the spark plugs through a distributor. It wasn't a distributor cap like it was later. It was a simpler mechanism. But up until 1912, motor vehicles, didn't really need a battery. There was no starter. So until 1912, a guy came along named Henry Leland. Yeah, that Leland, the car Leland, yeah. He invented the electric starter so you didn't have to hand crank the car. But once you had a starter, now you need a battery. So they developed the initially 6-volt battery as a lead acid battery for starting cars to avoid the hand crank. So you can see how even if you go down a path that's not the best path, as long as you tuck in a few improvements, change things a bit, navigate a little bit, you can take something that was not maybe the best path to start down, and you can squeeze it to be acceptable. Not a lot of precursors were needed for ICE vehicles until the people with the money came in and said, I can do that for you. And they did it. And that's how you took something that had problems and then suddenly didn't have problems. It took over 100 years, the cars that we have today, actually about 124 years to the cars that we have today. had you put 100 plus years into electric vehicle advancements, we might actually have progressed things a little further along. Because if you have an EV, oh, you need electronics, you need inverters, you need switching. So we might have developed semiconductors sooner if we had, 500,000 units in vehicles that needed triacs, which is a semiconductor switch useful for an inverter. If we needed to govern all that stuff, we might have developed computers sooner. So the computer that we needed during World War II might have already existed. This is just what ifs, because we have what we have, the history we have. So there are other impracticalities to sustaining sentient beings, ice worlds. Not that it's just chilly or cold, like this is so cold that even furs and igloos would offer you no defense. It might be 100 degrees below 0 Fahrenheit. In an environment that cold, even if you had some kind of outfit that would keep you from freezing to death, even inside of a cave, you wouldn't be able to do fine manipulation. So you wouldn't be able to build highly technical things because your fingers wouldn't work well enough. So let's say you're on an ocean world, like some of these ice-covered ocean worlds that are moons of Jupiter and Saturn. There's no dry land. How would you ever make metallurgy work? Are you ever going to get the heat you need to melt metals that you've drilled up from the ocean floor from a rock to make metals? Well, so smelting underwater is kind of impractical. What about chemistry? You want to formulate some chemicals. You would have to create tanks, which would require something like metal in order to do your formulation processing. And so it's kind of impractical to do that underwater. If your water happens to be salty, well, you can rule out electronics unless they started with optical electronics to begin with, because the salt water would short out any electronics. If you did have an ocean world, more likely evolution would have allowed you to develop fins, and fins don't have dexterous fingers, neither do like porpoises and whales. They don't have the ability to do any fine detail work. If you don't have an atmosphere that's combustible, also breathable, but combustible, like has oxygen in it, then you have no combustion for industry, you have no combustion for propulsion. So you can have a world like Titan, where you have so much methane that you actually have lakes of methane under pressure, very cold, but it doesn't explode because there's no oxygen. You can be on a world where somehow the beings are breathing methane, but absent any amount of oxygen. You're not going to have combustion, which means you're not going to have industry that likes to melt or cook things, and obviously no propulsion because there's no liquid oxygen for fuel or for oxidizer. Sometimes the way things come out is they just fit. You can adjust them slightly, but there's some simple, straightforward solutions to those requirements or the precursors. So if your only form of documenting things, recording things, is cave walls, you're not going to go very far. If you progress to stone tablets, again, you're not going to go very far. Although, Egypt did well. Or if you went off the branch of saying, we're not going to write on stone tablets, we're going to write on animal skins, they're only going to last so far. Or you can say, we've created this stuff called paper from rice or from cotton, and but it's kind of hard to duplicate things. So we've got this whole religious order over here called monks that will be doing all the writing for you, but they're only going to write what we want them to write. There's no freedom of documenting anything that needs to be documented. So you needed printing presses, you needed ink, you needed people that were savvy to that technology. So you need to be able to record on something that's lightweight, durable, and portable, and preferably a rewritable medium. Even carbon pencils, writing on paper, is kind of a rewritable medium because you can erase and then write something different down. That wasn't a 5, it's actually just a 3. Erase it, change it. But everything that we do nowadays, we look towards rewritable things. So we came out with paper and then magnetic. Magnetic had to be rewritable. And then we started out with optical. And the first optical were write once, read many, like CDs. And then we came out with DVDs, which were initially write once, read many. And then we decided, hey, we'll change the way that they work. We've got this thing called a Curie point that if we have a laser pop in there, we can actually change the effect of it optically and magnetically. And so we had rewritable optical discs. But then we said, can't get enough density, costs too much money. So we came up with these things called tunneling diodes, where if you apply a voltage through a material, it'll actually make an electron tunnel. And then when it creates the tunnel, you can then use that as a means of running the current back the other direction and detect whether it's 1 or 0. So flash memory, there you go, thumb drive. So you need something that you can write things on that is long duration, durable, that's rewritable, portable. If this sentient life has multiple digits, fingers, whatever they want to call them, or tentacles, but they have to be strong enough that the ends of them can grab and manipulate stuff. An octopus is kind of there, but they probably also have vision so that they can see things, perceive things, get their hands around things, adjust things, see the results of what they've done. But the vision that they have needs to be predominantly in what we would think of as the visible range. If they could only see in radio or infrared, things would be too fuzzy. You wouldn't get clear vision. And if they could only see in ultraviolet or X-ray, that would destroy cells. So a comfortable range is visible, where you get enough light in different wavelengths for detail, but it's not so high energy that it's going to damage the thing that's doing it. If you have digits and you want to count things, then you're going to have some means of manually recording what you've just made an observation on. Even an abacus. An abacus is something you digitally manipulate to show a value, or you can use it as a calculator. But you're going to create something that has a human interface to it that, it may eventually be buttons or a touch panel, or, the keyboard's projected on a surface and you just tap and block out certain light. But that's going to happen. Otherwise, you can't have electronics and computers and things like that. And you're going to need some kind of output interface. Maybe initially it'll be paper like green bar, or CRTs, or LCDs or LEDs, or eventually holographic, but you need some kind of thing to say, I'm doing some input, let's see what the output is. As computing capability grows, it needs to be shareable, pass along information, share the resources. So you're going to wind up with something akin to cloud-based, where things are connected and shareable. If they exist on a planet with multiple continents, then they're going to develop transportation, either ships or aircraft or something to get them from where they are to just over the horizon where they can see there's more stuff. And when they realize that takes too long, then they're going to develop communication, wired and then wireless, so that they can share, they can progress their advancements. Now, what would be up for grabs, like, I don't know, let's say the particular skin coloring or modeling of the individual. Will they, have spots down their skin? Will they be purple or green or, don't know. But those don't really make a difference as to whether or not they survive or are sentient. Also, depending upon the gravity, the particular height or weight of them, also variable. What language would they be speaking? Well, if they're smarter than us, they've finally concluded that one language for everyone on the planet is kind of a progressive thing to do. But unless they taught us English, I doubt that they'd come over speaking English. But they may be so educationally advanced that they learn it before ever arriving. It's kind of like people that study a foreign language before visiting a foreign country. Now, are they vegans or carnivores or omnivores? And what are their favorite foods? Doesn't really matter. Do they prefer to consume fresh things or processed foods? Humans like either, but the Klingons like only the predominantly fresh animal. Will they develop weapons of mass destruction and potentially annihilate themselves? That's always a way of knocking down a supposition that they might exist out there. Will they be flying around in aircraft? What will it be powered by? It'll probably start out simple and then complex. And will they be driving around in EVs or ICE vehicles? Doesn't really matter. It's up for grabs. But what about all the naysayers, the ones that say, no, it's not possible. No, you don't know what you're talking about. Well, don't be disheartened by all the naysayers out there. The Fermi paradox, the great filter, the zoo hypothesis, if it lasts long enough, it'll self-annihilate. There's lots of places in space. There's a non-trivial quantity of Earth-size or Earth-similar size exoplanets in habitable zones. A lot of them are around orange dwarf stars, which means they may have had a few 100 million to a billion years head start on us, certainly tens of thousands of years. And if you think about how far we've advanced in 10,000 years, gives them that opportunity as well. And they may be even more advanced, not only because they're around an orange dwarf star, but because they didn't take the left turns that we took due to derailments, either natural, things hitting the planet, or cultural or economic. So in conclusion, it's insatiable curiosity that drives us to ponder whether or not there is sentient life on exoplanets. There are precursors that must occur in order for things to progress. There are even certain precursors that without them, sentient life may be impractical. The environment just may not be suitable. And even with these precursors, there are things that just fit until they develop this, you can't have that kind of thing. And then even if they kind of get the ordering right, if something comes along that derails things, that can hamper progression. There'll always be some number of things that are up for grabs, but that's what adds the spice to life. Not that kind of spice. Now, it may seem like not too many links, but the first link is fairly heavy, and the last link is the abstract for an article about detecting artificial lights on Proxima Centauri b. And then the rabbit holes I went down. The history of the electrical grid, batteries, automotive use of batteries, internal combustion engines and mass production of them, Standard Oil in New Jersey or Ohio, vehicle tires, and the four wealthy industrialists will actually refer to as the four vagabonds. And then if you don't know about the anatomy of bamboo, there's the side turn. In a heavy gravity planet, what plant would likely survive? A variation of bamboo. Okay. So comments, questions?
Hmm.
I know where to start. So much.
Hmm.
Too much postulation
Hmm.
for a Saturday evening.
Yeah.
Well, I watch these things through various media, and they're always talking about either how exoplanet life should be out there, should be everywhere, and then they ignore the factors that preclude it. Or they say it can't be anywhere because nothing's been found that is a perfect clone of Earth. But I say you don't really need a perfect clone of Earth. You just need some precursors, some requirements satisfied, and then you need a period of progression. The progression can actually be slower than us or much faster than us. You have that variability.
So they can be around us now and we wouldn't know it.
Well, that's my thought is if an alien species looked exactly like us, for the most part, and learned to speak our language and maybe grew up in our environment and was educated in our environment, then they may be aware of themselves not being native, but they're probably going to keep it to themselves that they are not native. Because if you know what happens to people who come in without approval and other people have a problem with that, and then try to create a program that allows them to come in, and it doesn't go well. So expand that out to another planet. I mean, I'm taller than most people, but that doesn't mean I'm an extraterrestrial.
Sort of.
I read and learn about a lot of things. Back in the day, they used to refer to it as a fast learner. I'm a fast learner. I learn about technology because that's where the advancements come from. I explore that stuff. I go down the rabbit holes and find out all about this stuff. What are the edge conditions and the borders? But that doesn't make me an extraterrestrial. But it also means that I'm probably going to be less biased up front about the potential for extraterrestrials because I see so much variability in the human species on this planet that why would I want to deny even more variability? They're going to come in, they're going to take over. Well, if they were really that advanced and they wanted to, they would have done so by now. And what do we have as proof? I don't know. Spanish and Portuguese conquerors in South America. You don't need to be considerably advanced. You just need to be advanced enough and you can dominate an entrenched species. Well, that sounds like something we might have done had we encountered extraterrestrials back in the 1940s. But I think it's more a matter of they occasionally stop by to help us out. And then when we get to uppity, we think we got a good beat on things. We think we can survive on our own. Then they say, we'll come back later. But
it's unlikely to me that beings on another planet are going to look similar to us. I mean, look at the variability of life just on this planet.
Yes, but also...
And on another planet, it would evolve, I'm sure, very differently, different chemistry, different gravity, as you mentioned.
Yeah, but look at the variety. Look at the variety of people that are on this planet.
Yeah, people and then creatures.
Right. Well, I'm not considering the creatures because they don't typically build computers, or they don't have the dexterity to do it, or killer whales. There's a lot of smart things on this planet that just don't have the dexterity to do the things that we've done.
Yeah.
I look at the variety that we have here, but we're all the same. We're all the same biological form. Not a lot of 20-toed, 4-armed beings on this planet that are sentient. Except for an octopus.
Yeah.
Since they live underwater and they don't do too well outside breathing air, they're not going to be the dominant species on this planet.
That's probably smart.
Well, if you look at some of the things that they have demonstrated intelligence for, solving puzzles and the like, they're fairly smart creatures.
Yes. Yes, they are.
But I will have to say, back in my carnivore days, I've eaten a lot of appetizers in restaurants.
I still do.
Calamari. But, the more we progress, the less blinders we have on, the less confinement of our intellect, our reasoning, our openness to allow differences. So maybe we're not progressed far enough yet for them to come by and say hi again. But I'm hopeful.
Well, hopefully they get here before we aren't here anymore.
I've always found it interesting that UFO reports over places where nuclear weapons are stored always seems to be a thing. To me, that says maybe they're learning about the devices, and should we ever go nuts on each other again, maybe they allowed it during World War II as you need to learn. But we never went to the third bomb. And also, we even got smart enough to say, detonating stuff in the atmosphere is probably not a good idea. The cesium levels seem to be rising very quickly, and the worldwide cancer rates seem to spike. So not good. And then we learned that, even if we detonate them underground, occasionally they pop through the surface, and the wind picks up the dirt from the explosion and takes it to populated areas. So why don't we just do computer simulations of bombs? And that's where we are at the moment. So we eventually get smarter. Hopefully, we'll get even smarter.
Are you going to turn off the recorder?
I will turn off the recording now.